The quadratic formula. The quadratic formula is a formula that allows us to solve any quadratic equation in the form ax squared plus bx plus c equals 0. And it's derived from this pattern that we've been seeing when we've been completing the square. Only it's derived with these generic a, b, and c values. And so you can see the derivation here on the right, but I'm not going to go into it in detail. If you're interested, you can look up this derivation, just do a YouTube search or a Google search, and you'll be able to find lots of pages or videos that will help or will guide you through this derivation. But really being able to do that derivation or being able to follow it is not necessary. Just being able to use the formula itself is what's required. So if we have a quadratic equation of the form ax squared plus bx plus c equals 0, then x is equal to negative b plus or minus the square root of b squared minus 4 times a times c, all of which is divided by 2a. This is the quadratic formula, and it gives us solutions to x, and you can see it has those features we would expect, like two solutions, positive and negative, a square root, only it doesn't require us to complete the square. It doesn't require us to do any work besides write the quadratic equation in the form ax squared plus bx plus c equals 0. The quadratic equation is pretty straightforward. I mean, it's sort of a big looking equation, but all it really is necessary for using it is just being careful with your mathematics, multiplying correctly, adding and subtracting correctly, and then simplifying correctly. So let's show you an example here. Here we have an equation 2x squared plus 9x minus 5 equals 0, and we're going to solve it using the quadratic formula. So what I'll do, I'll go ahead and write the quadratic equation out, negative b plus the square root of b squared minus 4ac, all of which is divided by 2a. On future questions, I won't write out the whole formula. I'll instead just start plugging in the values. But on this first example, I just want to show you where all those values are going and to be careful about this. So we are going to use this. I'm going to start my work here. X is equal to, and I'm just going to try to color code this. So I'll use green for A. So that's A, green. And B, I'll do in purple here. B for 9. And then in gray, I'll do C. Now C is negative 5. The negative here belongs to the value of c. So when I put c into the equation, I have to make sure to put negative 5 into the equation. Now let's go ahead and start substituting these values. So x is equal to negative the b value. So that would be negative positive 9. So negative 9. Plus or minus the square root of b squared, and b is 9. Then we have subtract 4 times a times c. So a in green is 2, and c in gray is negative 5. So make sure to get that negative in there. It's very important. And then we're going to divide all of this by 2 times the a value, and a is equal to 2. So the quadratic equation is really nice. You throw those values in there. We have to do nothing now except to simplify. However, simplifying is not always a super easy task. We have to be careful with our mathematics. So we have negative 9 plus or minus 9 squared is 81 minus, now I have negative 4 times 2 times negative 5. So negative 4 times 2 is negative 8 times negative 5 is positive 40. So I have negative 9 plus or minus 81 plus 40. And if that sign was done incorrectly, we would get very different results. So it's very important to make sure you get your signs correct. And then all divided by 4. So I have negative 9 plus or minus 81 plus 40 is the square root of 121, all of which is over 4. And luckily, 121 is a perfect square. So we can recognize that this is 9 plus or minus 11 over 4. And so that's what we currently have for our value of x. But we can simplify this quite nicely because negative 9 and 11, those are integers. We can add and subtract those together. So I will write my two solutions as, let me continue my work up here a bit. So negative 9 plus 11 over 4, or negative 9 minus 11 over 4. So negative 9 plus 11 would be 2 over 4, which I could write as a half, or negative 9 minus 11 is negative 20 over 4, which is negative 5. So x is equal to a half, or x is equal to negative 5. So that's the pattern for these problems. We put those values into the formula, and then we simply simplify it, being very careful in all of those intermediate steps. And now I'm going to start going quicker through some examples here. Now, I have the quadratic formula memorized because I've used it so many times. You probably don't have it memorized yet. So what I suggest when you're working on these problems is that you just have a copy of the quadratic formula nearby, so that you can refer to it as you're solving these problems. And on tests, you will be given the quadratic formula in this course. So you don't have to have it memorized. You just need to be able to find it and then use it accurately. So let's go ahead and get into it then. So we have we have x equals, and then in the fraction at the top, we have negative b. So that's negative 10 plus or minus the square root of b squared. So I'm just going to do b squared and get it as 100. Get that math out of the way. And then minus 4ac, so that's 2 times 11. All divided by 2a, and 2 times 2 is 4. So you can see I do some steps when they're simple to do, but I don't try to do too many in one place. So I have negative 10 plus or minus 100 minus 4 times 2 times 11 is negative 88, all of which is over 4. So negative 10 plus or minus 100 minus 88 is 12. So this is plus or minus the square root of 12 over 4. And this is where being very careful with our simplifications is going to be important. So I have to reduce this radical because it is reducible. So the square root of 12, I can rewrite that as plus or minus. Well, 12 is 4 times 3, and the square root of 4 is 2. So I can rewrite square root of 12 as 2 times the square root of 3, all of which is over 4. And now I want to simplify this further, because here I have two terms above a fraction, 10 plus 2 root 3 or 10 minus 2 root 3, but both are divisible by 4. So I want to simplify this by dividing the top and the bottom each by 2. Sorry, I think I just said that they were both divisible by 4. That's not correct. Each of these terms is divisible by 2. So I'm going to go ahead and divide everything by 2. So you have to make sure to divide both terms in the numerator by 2. So that would be 10 divided by 2 is negative 5, plus or minus 2 root 3 divided by 2 is just root 3. And then 4 divided by 2 is 2. And that's as simple as it gets, because I have negative 5 plus or minus square root of 3, so that can't be combined, and there's no more common factors, so there's no more simplification to do fraction-wise. if an equation isn't written in quadratic form, then in order to use the quadratic formula, we just have to write it in that form. So expand out this multiplication, so x squared plus 6x plus 4 equals 0. And now we have a quadratic equation that we can plug into the quadratic formula. So x equals, and we have our big fraction, and it will be negative b. So that's negative 6 plus or minus b squared, so 6 squared, minus 4 times a. And here we notice that the value of a is just equal to 1 because there's nothing in front of the x squared term, which implies that it's just 1. And c is 4. And then all divided by 2a, so 2 times 1. Now we just begin our simplification. So negative 6 plus or minus square root of 36 minus 4 times 1 times 4 is minus 16. And then all of which is divided by 2. So this is negative 6 plus or minus the square root of 20 over 2. And the square root of 20 can be simplified. The square root of 20 is equal to the square root of 4 times 5. So that would be 2 root 5. So this is negative 6 plus or minus 2 root 5 over 2. And again, we can see that there is a simplification that can happen because all of these can be divided by 2. So I can divide both the top and bottom by 2. So all terms are divided by 2, and I get x equals negative 6 divided by 2 is negative 3 plus or minus the square root of 5. And 2 divided by 2 is obviously 1, which I don't have to write.